I'm going to quickly go through the presentation because, again, it's 12 minutes and I have got actually quite a lot of information stuffed in it. So bear with me if it's too heavy, the presentation itself. But that's what I'm going to talk about: designs of container ship, two notorious cargoes, and basically what we should do, not just a ship owner, but everyone who's involved in container shipping. Anyone in the room who does not recognize that picture? Okay, everyone does. Yeah, it's Maersk Honum, and a fire broke out on 6 March, and yes, there you have the statistics. 5 people died. The fire burned for more than a month. There's another one. It's Hyundai Fortune. And this is MSC Flaminia in the North Atlantic in 2013. This ship also burned for 3 weeks almost. 4 people died. And then the ship was supposed to go in a place of refuge, but none of the countries would take the ship in because it was actually throwing out a lot of toxic fumes into the air. Finally, Germany took it because it flew the German flag, and then of course they waited for fire to burn out, which was almost more than a month, and it went into a safe haven 3 months after the initial explosion. But if you look at the official report of this accident and you look at what cargoes were there, you would find a list of these chemicals. This is just a part of that list, and it's also what has been officially declared on that ship. That many number of chemicals is normally carried on a chemical tanker, so you tend to think whether this is a container ship or a chemical tanker. That's just a thought. But why are these happening lately in the last few years? Containers have been since 50 years. You look at that, that's how container ships have been growing. And if you look at in the past 50 years, there has been a 120 times growth in terms of size of container capacity. And earlier on, tankers and bulkers used to be much bigger, but now containers are one of the biggest floating ships. Why? Well, actually, why not? Because there's an increased economy. People want more goods. They probably don't need it, but we want it. We want 2 TVs. We want more and more. Competition, because another company is ready to provide it. And you can use the economies of scale, which is what tankers have been doing. They have been transporting cargo at a very cheap rate. Why not containers? And you have the technology. Yards are able to build big ships, new technology, so why not? And that's how it has been growing. This is the main reasons of causes of fires. Misdeclared and non-declared is probably one of the main ones spoken about, but I'm not going to go deep into that, but I'm going to look into the other couple of things. Now, this is a typical container ship, and if you look at it, that little box is actually a cargo hold of a container. And what we have as a fire detection system is what you see on top is a smoke extraction system. You don't have detectors like this into cargo holds of a container ship. What they do is they extract the smoke from top of the hold. So if you see the smoke goes from top of the hold, it travels through to the accommodation, and then it goes up to the bridge, and the sensor is on the bridge of the container vessel from where it detects whether there is smoke, and then you get an alarm. So it takes time for the smoke to travel up there. If there is a fire in the middle of the hold, in the bottom container, it takes time for it to come up and then travel to the bridge. The second one, there is also a ventilation system. So because there is a lot of different cargoes in the containers, you need to ventilate that, and pretty much almost 6 times of air exchange per hour. So when there is a small smoke, actually the ventilators work against the smoke detection system, and it will not send the smoke to the bridge, but it will send it out. So you really have a big fire before you actually see an alarm on the bridge. But that's the design that we have today. This is how traditional firefighting is done. They say this is the fire triangle: oxygen, heat, and fuel. You remove one of this, you can extinguish the fire. And we have CO2 systems, and that's how people traditionally fight fire. But we have some of the cargoes that we carry today actually burn not by a physical reaction, but by a chemical reaction. Now, this is two simple reactions. One is endothermic, which means it actually absorbs heat. It leaves a cooling environment around it. But the other chemical reaction is exothermic, which means at the end of the reaction, it produces a lot of heat. And one of the cargoes that we carry is this one. This is a very notorious cargo, calcium hypochlorite, used as a chemical to clean swimming pools, water cleaners, and all these big water pools. But if you look at the cargo, it says it's actually non-flammable. It's not at all flammable. But it is an oxidizer, which means when it breaks down, it produces oxygen, and it produces a few gases which can actually inflame the cargoes around it. And you don't have to do too much to do it. All you need to do is increase the temperature a bit. So in ambient, very ambient temperatures, it's quite stable. But you increase the temperature, it decomposes, you increase some more, and it decomposes rapidly and releases a lot of heat, which is good enough to actually bring the cargo around it to their spontaneous ignition temperature. And you can create a fire. And this is a chemical reaction. You don't actually have a fire, it just happens automatically. The second one now, this is interesting. This is lithium batteries. That's right there on top of the graph. If you look at the vertical axis, this is actually how light a battery can be. And on the horizontal axis is how small a battery can be. And that's what we want today. We want smaller batteries, we want lighter batteries, but we want more power. And if you want to do that, lead acid is probably not the answer. Lithium batteries are the answers. But what happens when you carry these lithium batteries is that since they are so small and you have a lot of charge, you already have enough energy stored, and these batteries can catch fire if you create some sort of stress. And that can be a mechanical stress, it can be thermal stress. Again, slight increase in temperature or even a mechanical damage, and they can start burning. There's another stress which is electrical, but that doesn't normally happen in a cargo hold. That little picture there, it's a result of an experiment, and I have removed all the graphs because that'll take a lot of time for me to explain. But what it simply says is that if you burn a battery which is charged, it releases CO2 a little bit, but it releases a lot of carbon monoxide and hydrogen. On the other side, if you burn a battery which is not charged, it only releases CO2. So the carbon monoxide is very, very toxic, very toxic. So that's one of the reasons we have toxic smokes coming out of the cargo. So what do we need to do? I'm not proposing solutions, but I'm just pointing out to the problem, saying that we need to study our fire detection, fire protection, and firefighting systems. This is something that's already there on ships, not on container ships, but on tankers and gas tankers. The one on the left is a water curtain that is a very standard feature on gas tankers. You have it in front of your accommodation. So if there is a fire, your accommodation at least is saved. If you look at Maersk Honum, the accommodation burnt, and that's why people did not have enough time to even react. They just had to quickly leave the ship. But this one here is an automatic water spray system on a tanker, also on a gas tanker. And this is a fire monitor. I'm not saying foam monitor, but it's a water fire monitor permanently installed. If you have a permanent monitor, you can have a much powerful monitor rather than a fire hose or a portable monitor. Just some ideas. And what else? Well, if we want to carry a container, a liquid cargo, and if it's expensive, we use these tank containers, and this has got safety features. It has got relief valves that ensures that that there is no explosion. It has got a spill container as well, so that if there is a spill, it's contained in it. If you want to carry perishable goods, we carry a reefer container, and much more expensive, but we do it. But when it comes to dangerous goods, we still carry it in normal containers. Why not design a container that has an inbuilt fire sensor and an inbuilt temperature sensor that can tell you a rise in temperature, or even an inbuilt firefighting system? It's not there yet, but I'm just trying to think that could be one of the solutions that we can look into to sort of tackle this problem. And yeah, that is all I have. Thank you very much. I have actually finished in 10 minutes, so I give you your 2 minutes back.